Hello everyone, in this video we will discuss about post-weld heat treatment. Just like preheating, post-weld heat treatment is very important for as a part of welding inspection, and in this video we will cover introduction and importance about post-weld heat treatment. Now let's understand about post-weld heat treatment. So post-weld heat treatment starts after the welding process. Here, word after is very important. So when you finish the welding and your metal is still hot, you can apply this process. So you have to start the process right after that. It can be manual or semi-automatic, and it helps to improve welding quality and stress relieving. Now welding quality means not only quality of the weld metal but also the quality of the base metal which is next to the weld metal. And stress relieving means there are internal stresses which are generated around the weld area, and you have to get rid of those stresses, and that is considered as the stress relieving. So here you can see an example of the weld joint, and this is how you can see from outside. So outside it's just a connection between two metals with the proper welding application. But if you try to see them internally, you can see there are different temperature distribution throughout the joint, and this temperature is different at different locations. So the center area is very hot, then the next adjacent area, and the finally base metal. So the center area is your weld metal, then your heat affected zone, and finally your remaining area. So temperature is distributed differently throughout these three zones, and because of that different stresses are generated, that is called as the residual stresses, and also quality of metal in these all areas are different right after applying the welding or while welding cools down and become a homogeneous material. So we were discussing about the metallurgical changes after the welding, and this is why post-weld heat treatment is very important to control the metallurgical changes. Let's see an example of a weld cross-section area. So as you can see, this cross-section area after the welding, there is a heat transfer between weld metal and base metal, and that is because of the conduction heat transfer. So as you can see from the weld metal, the heat is transferring from weld metal to base metal in all direction, and that is why there is a temperature difference. So temperature always goes from higher temperature to lower temperature region. So as you can see, different layers or different areas, and these all layers and all areas are having different temperature. So that is because of the uneven heat transfer. Sometimes uneven heat transfer is also because of the thickness. So sometimes the heat transfer to the thick area, thin area, so all temperature distribution is different. And once that start cooling, it depends on the ambient temperature, and also cooling rate changes based on the circumstances. And because of this all, residual stresses, internal stresses, they are generated, and because of that residual stresses and cooling rate, there is a hardness value which always changes, and that makes a brittle structure. So to understand about the hardness, let's see an example of a weld cross section area. So as you can see the weld cross section area here, hardness value H1, hardness value H2, and hardness value H3. So these all hardness values are at the different location from the weld metal, and because of the cooling, hardness changes. So there is always a higher hardness near the weld area and lower hardness further towards the weld area. And because of the different hardness, it makes it brittle structure. So brittle structure, it fails whenever there is an application of the heavy loading. So controlling the hardness is very important, and controlling the hardness, cooling rate and cooling of the weld metal and base metal is very important to understand, and this is why post weld heat treatment comes in the picture, which slowly allow weld metal and base metal to cool down. So because of the slow cooling, less residual stresses and uniform hardness value, which makes your whole weld joint homogeneous and better for the performance. One more disadvantage of the uneven cooling without the proper post-weld heat treatment is the cracking issue, and that happens right after the welding within 24 to 48 hours. So as you can see this weld cross section area, because of the residual stresses generated between weld metal and base metal, especially at heat affected zone, these stresses try to pull weld metal and base metal in opposite direction, and because of that there is a crack generated, or there is a failure underneath the weld at the heat affected zone. There is also uneven grain structure because of the cooling near the weld area and further from the weld area. So if you see the microscopical structure near the weld area and further from the weld area, that is different, and that also causes uneven structure internally. Sometimes if hydrogen is entrapped and there is a residual stresses because of the cooling, that is also one of the major reason for the cracking. So to avoid these all circumstances, post heating is very important, and it's mentioned in the code what type of metal require what type of post heating, and also stress relieving. It is also very important to get rid of the residual stresses. So here post heating and stress relieving are needed as a part of post weld heat treatment to get rid of all cracking and uneven metallurgical issues. So like I was mentioning that post weld heat treatment detail is mentioned in the code. So ASME section number 3 is providing us the detail about the post weld heat treatment, when and how to apply the post weld heat treatment, and it mainly depends on the P number, that is the metal categories, and P numbers are mentioned in section number 9. So based on the different P number category, section number 3 shows post weld heat treatment value. It mainly depends on thickness, time and temperature, and thickness means the thickness of the base metal. Mainly it is a part of WPS, welding procedure specification. So if you see WPS, there is a detail, and there is a detail about post weld heat treatment is given. So as you can see this welded connection, first of all you have to see type of the metal, and that will decide your P number. And once you know your P number, all you need to know about the thickness of that metal, and once you know the thickness about it, how much time needed and how much temperature is needed, that is given in the section number 3. Sometimes inspector do not have the in-depth knowledge about the post-weld heat treatment requirement or in-depth knowledge of the code. So let me discuss some basic key factors which inspector should consider to think is there any preheat or post-heat required for this project or not. So first of all, the most simple way to do it is to refer specification for that drawing and also try to refer WPS, and you can see the requirement in the WPS. Then if there is a preheat required for that metal, then there is a higher chances that there might be post-well heat treatment required as well. So imagine if there is no preheat, then there is very less or few chances of the post-well heat treatment. Also the hardness distribution. So if you are doing some test, and if you see after welding that if you try to see the hardness with the hardness testing machine, and you see the major difference between hardness near the weld area and further to the weld area, then you should talk to engineering, or you should decide that this may require post weld heat treatment to uniformly cool down to maintain the hardness throughout the structure. This is where generally in WPS requirement of the post weld heat treatment is mentioned. One more useful tool for inspector is to understand the base metal properties, and based on base metal properties you can understand the weldability of that material. So all you need to do, get the material certification, that is your material cert, and you can see various chemical properties in that material certification. So there is a carbon contain, manganese contain, phosphorus contain, sulfur contain. So all different contains are there. So all you need to do is to see carbon contain, and based on carbon contain you need to understand this table. So when you see the carbon less than 0.15 percentage by weight, it considered as a low carbon steel, and this is its application. And post-well heat treatment and preheat is not common in that. After 0.15 percentage to 0.30 percentage, that is your mild steel. This is the application of it, tubes, pipe, plates, etc. And here preheat and post-weld is also not common. For carbon 0.30 to 0.50 percentage, that is your medium carbon, and it used for the machining component, preheat and post-weld heat treatment is required. And finally for 0.5 to 0.99, that is your high carbon, mostly for cutting tools, preheat and post heats are mandatory. So all you need to know carbon contain from the material certificate and try to judge that is there any role of preheat or post-weld heat treatment or not. And finally, inspectors with having some engineering background knowledge, this is your iron carbide diagram, and based on the iron carbide diagram you can judge the need of post-weld heat treatment. So as you can see on the x-axis there is a carbon content given. So based on the carbon content, if you go left to right, carbon is increasing, and that is giving you different type of steel. And for the given carbon, as you can see the temperature distribution on y-axis, you have to heat the metal up to certain degree after the welding to achieve the desired metallurgical structure, that is a different type of steel. And then you have to slowly cool down, and this is one of the technical understanding or idea about the post-weld heat treatment. Finally, let's see the advantages of post-weld heat treatment. So base metal properties like hardness, ductility and tensile strength, they are improved by post-weld heat treatment. You can get the uniform hardness, and that is obviously helpful for the better performance. So that should be an equal hardness throughout the structure. The parts which are post-weld heat treated gives you a better machining performance, because the structure after the post-weld heat treatment is uniform, and that is very effective for machining process. This is very important thing. It minimizes the effect of minor welding defect. So there are some residual stresses, and based on those residual stresses, if there are welding defect inside the metal, they are more threatful compared to the defects without residual stresses. And finally, results which we are able to achieve after post-weld heat treatment are mentioned in the PQR, that is your procedure qualification record, and based on that you can judge to change parameters and also change values to improve your welding quality. Thank you. There is obviously a lot of information and understanding and learning about post-weld heat treatment, but I try to keep this video short. In case you want to know anything specific based on this topic, please write down in the comment section, and please subscribe to my channel and let me know in case you need to cover any specific area related to welding inspection. Thank you.